In this lecture, we're going to talk about two things, about feature theory in phonology and about optimality theory and correspondence theory, which are constraint-based models of phonology. So at the end of the lecture, you'll know the motivations for phonological feature theory, how segments are defined in terms of features, where to find complete feature vectors, the advantages and challenges of constraint-based phonology, and what OT and correspondence theory are and how they work, and what the relationship is between markedness and faithfulness. And you'll be able to do two things: identify a natural class using phonological features and evaluate an optimality theory tableau. So the idea of feature theory goes back to the idea of a natural class. Natural class is a group of phones, a group of segments, really, that behave the same, like they play the same role in a rule, or they have the same kind of distribution. They occur in the same place in a syllable, for example. They have the same behavior phonologically, and they share some kind of phonetic property in common. And so they're classes because they share the behavior in common. They are natural because they're grounded in phonetics. And in the early 20th century, then some people like Leonard Bloomfield came up with the idea of decomposing individual segments into features, into smaller components that correspond to these natural classes. So, for example, with vowels, it's very common for vowels that are high to behave together phonologically. So these vowels. And it's very common for vowels that are not high to behave together, behave like one another. So these vowels. And in fact, the low vowels also pattern as a unit in contradistinction to the high vowels. And back vowels often behave in ways that are different from front vowels. So these are captured through binary features. So plus means the feature is active, minus means the feature is inactive. So a high front vowel is plus high and minus back. And each of these features, high, low, back, and round, corresponds both to a natural class, or both to a phonological class and to something phonetic. So they capture natural classes. Here are some consonant place features. This brings up another thing. So we've talked about plus, we've talked about minus, but we haven't talked about neither plus nor minus. This means irrelevant or unspecified. So anterior means that something is produced in the front of the mouth. Coronal means that it's produced with the tip or the blade of the tongue. And distributed means that it's produced with specifically the blade. So the tongue is spread out. The closure is spread out. It's distributed. Distributed only is relevant if you're talking about a coronal, because this is the only kind of sound where you could have distributed the closure. You note that high, back, and low are also vowel features, but they're used as consonant features as well. And this makes sense because you have assimilation in some of these features between consonants and vowels. And it's easier to write the rules, which you can do in terms of features, if you do it using the same features for those aspects of place. So let's say you've got IPA data and you want to get feature representations, vectors of these features for each segment in that corpus, in that collection of data. One way that you can do that is with a piece of software called Panphone. It's a Python library. You can install it with pip. It's compatible with Python 2 or 3, though you should use 3. And it does other things with features that can be useful if you want to manipulate them. It's compatible with Epitran, with the G2P system Epitran. So if you're using Epitran to get IPA, then you can use Panphone to get features. Another possibility, oh, here is an example of what it looks like. So you import Panphone and create a feature table object. And then you can call a method called word features on the feature table object and pass it string, and it will give you back a segment. And this is how this is linearized. It just shows the an array of the different features and their values. But then you can ask it, for example, is the first segment plus coronal? Does coronal have the value 1? And it will say true, because S is plus coronal. If you ask if W is plus coronal, then it will say false. And you can also take the whole thing and convert it to a vector, non-numeric or numeric vector, which is represented as a list of feature specifications. Another database of segment inventories, or of features, is part of Foible, which is really a database of segment inventories for a large number of languages. And for each segment in each inventory, then there are a list of phonological features. So the system is similar to, but somewhat different from Panphone.